Hello there, friends. Today I'm going to be solving a problem 1.47 from Introduction to Mathematical Statistics, 8th edition by Hogg, McKean, and Craig. And this is a two-part problem. Part 1 says you roll a pair of dice till you either get the sum of 7 or 8. And you're being asked, what's the likelihood, what's the probability of rolling a 7 before and 8. So 7 before 8. And so first things first, I'm going to write what's the sample space for each 7 and then 8, and then I'll proceed from there. So to get the sum for 7, what you need to do, the rolls you would get are 6, 1, 5, 2, 4, 3, and then you can just invert these. The reverse is also the sum of 7, so you can just multiply these by 2. 1, 2, 3 times 2, that's 6. And for 2 dice rolls, that's 6 times 6, 36. That's the entire space. So the probability of getting the sum of 7 is 6 over 36. And I'm going to leave it like that without reducing it. Just it makes the problem easier longer on. For 8, it's 6, 2, 5, 3, and then 4, 4. Now here it's similar in that these two can be reflected. So you can multiply this by 2, but only these two. 4, 4. If you reverse the pairing, it's still just 4, 4, which is the same. So you don't count that. So here it'd be 1, 2 times 2, which is just 4, plus the 1. So for 8, you have a 5 in 36 chance of rolling it. So now the question asked, what was the probability of rolling a 7 before an 8? Which changes how things work a little. And so one way to conceptualize it is that you don't really care about any other rolls except 7 or 8. You could just keep rolling and rolling and rolling and rolling. It does not matter. You can keep rolling ones infinitely. The only thing that matters is that you get a 7 before and 8. And so one way to think of that is one way to think of that is like this. So you have your 6 over 36. That's your 7. The probability of getting a 7. And given that this is it's sort of a posterior problem. This is like a modified Bayes. You would have your 6 over 36. Your sample space here instead would be 5 plus 5 over 36. Because the only two rolls that matter are 7 and 8. This is equivalent to saying 7, the probability of rolling a 7 over the probability of 7 plus probability of 8. Since, again, these are the only two rolls that matter to us, so we don't have to take into account the rest of the sample space. And so this becomes pretty easy. This is 6 plus 5, which is 11 over 36. Since you're dividing, that's multiplying by the reciprocal, which is just 6 over 36 times 11, which times 6, 36 over 11, which is 6 over 11, which is what you were supposed to find, which is the probability, 6 over 11. That's the answer for part A. Now, part B, it gets a little more complicated. So we're being asked, we're still rolling the same pair of dice. Except this time, the dice stops when we either roll a pair of 7s, the sum of 7s, or a 6, then an 8. And so we're being asked, what's the probability that we'll roll the sum of a 6 and the sum of an 8 at least once before we roll a 7, a sum of a 7 and a sum of a 7. So here, the order doesn't necessarily matter. We can roll the 8 sum first, and then the 6, and so forth. Now, the reason I say this is a little more complicated is because of how you can get this different value. But I'll show you that in a sec. So first, I'm going to write the sample space for 6. The probability space, I mean, for 6. So you know the different ways you can get it. So 6 is just 5, or dice roll of 5 and 1, dice roll of 4 and 2, and a dice roll of 3 and 3. And just like 8, these two times 2, this is just the pair can't be reversed, so this is just a 1. 2 times 2 is 4, plus 1 is 5. So the probability of getting the sum to be equal to 6 of 2 dice rolls is 5 over 36. Now, you may have noticed that this is the same as rolling the sum of an 8, and this symmetry will come useful in a second. And so, the different ways you can roll at least a 6 and 8 before a 7 are as follows. So, first, you can roll a 6 before a 7 or an 8, and then an 8 before a 7. In this case, you roll no 7s at all, just the 6 and then an 8. I'll put this down as A, just so I can keep track of the different variations. It should be noted that you can roll at least 1 7, just as long as you don't roll the pair before you roll the 6 and the 8. And it should be noted, in case it gets a little confusing, these are the sums of the 2 dices, not an actual dice roll number. And so for B, it's getting a 6 before a 7 and an 8. Then you roll a 7 before you roll your 8, and then an 8 before another 7 dice roll. Then you can also write, you could just have a 7 before anything else. So that's before 6 or an 8. Then a 6 before a 7 and an 8, because if you roll another 7, the game ends there. And then an 8 before a 7. And because 6 and 8 have same probabilities, you can do a little symmetry here, just like we did with the other ordered pairings, by saying you could just flip the 6 and the 8 here. And so you take this and you multiply it by 2, and that's all the different ways in which you can get a 6 or an 8 at least once before you get the sum of 2 7s. Now I'm going to solve A, B, and C first, so you have those probabilities, and then we'll solve the entire problem. And so for A, to get a 6 before a 7 and an 8, this is just 5 over 36. 5 over 36, because this is just the 5, and then the probability of getting a 6 and 6. Then this is an 8. This is for 8 over 36. And then a 7. For the 7, it's 6 over 36. This is similar to the first part, where since we only care about the specified rolls, the rest of the rolls don't really matter at all. So this is the probability of getting a 6 before either a 7 or an 8. And I'll do this, I won't go through the whole cancel and all that. This is just 5 over 16. And then it's the probability of getting an 8 before a 7, which is just, we've already done that. That's just 5 over 11. And you multiply these two, and that should give you 25 over 176. So that's how you solve that first possibility of getting your 6 and 8 before your 2 pairs of 7s. Next, we'll do this one. It's again 6 before 7 and 8, which we already solved for. That's 5 over 16. Then it's a 7 before and 8, which is what we did in part 1. So that's just 6 over 11. And then it asks you for an 8 before you get your second 7, which is just 5 over 11. And you multiply this out. That's 150 on the top over 1936. And next, I'll solve for C. For C, it's getting a 7 before a 6 and an 8. So similar to getting a 6 before 7 and an 8, this would just be, just to write it out in case, 6 over 36, 5 over 36, plus 5 over 36, plus 6 over 36. You add these, then multiply by the reciprocal. 36's cancel out. And to save me space, I'm just going to write it out here. That's just 6 over 16. So next, we have, this is the part C where it's 7 before a 6 and an 8. Next, it's a 6 before an 8 and a second 7, which is just, we solved this already. That's just 5 over 16. And then it's just an 8 before a second 7, which is 5 over 11. Multiply this out. That's 150 over 2,816. Now, we're almost done with the problem. Now, the probability of getting a 6, at least one 6 and 8 before getting 7 twice for the sum is just this. 25 over 175, which was A. 150 over 1936 plus 150 over 2816, since these aren't independent. And of course, since that only accounts for 6 for half of it, so this was just to get the full space. That's times 2. And you add, multiply, divide, all that good jazz. It just turns out to be 0.546, which is the solution and what we wanted to show. Now, if you have any questions or need anything clarified about this specific problem, feel free to let me know in this comment section. If there's anything you would like me to solve, I'm fairly well versed in mathematics. Anything below an undergrad, anything undergrad and below, I can solve with relative ease. Just feel free to let me know in the comment section, and I'll do that as well. Thank you for watching, and I hope you have a nice day.